Okay, so we'll start the session now. So yeah, so mostly we'll revise the concepts of quiz 2. So I'll start from week 5. Okay.
Okay, sir. Good morning.
Good morning. Good morning to all. Okay, so I hope my screen is visible.
Yes, sir.
Yes, sir.
Yeah. Okay, so I'll start with maybe function. So okay, so suppose I have a map. So suppose I have a function. So suppose I have a function from the set A, and A is nothing but A is a subset of our real number to B, and at the same time B is also a subset of real number. Okay, so F is a map from A to B. So when I'm writing, when I'm saying F is a map from A to B, so that basically that automatically implies that A is the domain of the function. Okay, so A is the domain of the function and B is the codomain of the function. Okay, so F is a map from A to the so domain is A and codomain is B, and by the property of the function for each given input, so function should always produce me a output once I give a input. So each point in the domain, so if X is a element of A, so then I should get a output in my codomain. Okay, so if I have input, this is input and this is I'm getting output in my set B. So in this particular week, we are more concerned about some special type of function. Okay, so that function is basically one function. Okay, so so the definition of one function is so one function is basically if so if I have two distinct element in the domain, then I should get two distinct element in the codomain. So in other words, image of two different element are always different. Okay, so if I have a map, a function, just stop me if you have some doubt. One if no elements, if no two elements in the of F, correspond to the same element. Correspond to the same element in the so what basically it's saying, so it's what basically it's saying, no two elements in the domain correspond to the same element in the codomain. So basically saying if so f is a map, right? F is a map from the set A to set B. So it's saying I don't have two elements x1 and x2 that maps to the same element, some f of x1. So both of them don't map to the same element in the codomain. Okay, so we can write it in some other way also, like it's basically saying if I have for any two elements in my domain, the image of these two elements is different. If I pick two elements, x1 is not equal to x2, then their image are also different. Okay, so if a function satisfies this condition, then I say my map is a one-to-one map. Okay, so there is another way to basically there is another way to write down the same thing. So I can write also. So there is one other way to write down the same thing, that is, so that is basically if f of x1 is same as f of x2, that means x1 is equals to x2. Okay, this is also a property of one function. So as you can see, this whatever this statement and this statement, they are basically same. Okay, so the first statement is saying if I pick two element in the two different element in the domain, then I should get two different elements. Okay, and second statement is saying if the image of two elements are same, then both the elements are same. So second element indirectly saying that if I pick two different elements, then I should get the image should also be different. Okay, so the definition is clear.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So okay, so for example, let's take an example. So let's take an example. Consider this map from the set of real number to real number. So this is nothing but x goes to modulus of x. So I want to check whether this map is one-to-one or not. So what is your answer?
No, sir.
Why?
Mod x. So
Mod-
whatever the input we are giving, this will be positive. If we give -1, this will be 1. If we give 1, this will be 1.
Yes,
So
correct.
if x function of x will be same for two numbers.
Correct.
it is
So one-to-one. So if we go and check the definition of one-to-one, it's basically saying if I take two different input, it's saying that their image should also be different. Okay.
yes.
But in the case of modulus function, so as you can see the graph, So if we draw the graph of the modulus function, so this is the graph of the modulus function. So as you can see, if I take the output of the function at x equal to 2, and if I take the output of the function at x equal to -2, so at these two different points, so here x1 is -2, x2 is 2. As you can see, their image are same, right? So that basically contradicts the definition of one-to-one function. So I have two different x1 and x2, but their image is basically same. Okay, so so what we are getting x1 is not equal to x2, but f of x1. So x1 is -2, x2 is 2, but f of x1 and f of x2, they're equals to 2. So this map is not 1-to-1. Okay, so okay, so let's take suppose this example. So let's say this one. So this is a map from R to R. So this is my okay. So the next question is whether this function is 1-to-1 or not.
No, sir. It's not one.
Sir, not one.
No,
And why?
Sir,
because -2 is 4, +2 is also 4, and we add 45. We will
Correct.
get in both cases.
Correct. So the problem is so the problem is this one, this x square term. Okay. So this will create the main problem. The same argument. If I try to compute f of 2, then I will get 49. And if I compute f of -2, then also I'll get 49. Okay. So x1 is 2, which is not equal to x2, which is -2. But if I take their image, so I'm picking two different elements in the domain, but if I take their pre-image, then they are same. Okay, so that means this function is not 1-to-1. Okay, so I'm getting some echo, I guess. Can you mute?
Sorry, can't repeat you, sir.
No, fine. Yeah. Not 1-to-1. Okay. Okay, so let's take one more example. Let's say f of x is
Sir, one example for root function, under root x to x2.
okay. So
1-1 function. So 1-1
yeah.
function.
So why
This is one-on function, one-to-one.
why this is 1-1 function?
Sir, because
we
in
put-
different x1, it will give different images. For different inputs, it will give different outputs.
Correct. So can you help me to write it down?
Yes, sir. If we take F5, then
Sorry?
it will. Sir, if we take F1, then it will give a 3. And
No,
if
so you are basically giving some specific thing.
value.
So
Yes,
yeah,
sir.
so when we need to prove that a function, see, to disprove this function, so the definition of function says like a function is 1-1 if it is satisfied for all x1 and x1 not equal to x2, right?
Yes, sir.
So if I provide a simple example, then it is enough for me to disprove that this function is not 1 to 1. Okay, but when I am saying that this function is 1 to 1, then I have to show it for all x1 and x2, right?
Yes, sir. Then by making graph,
No, so yeah,
If we put x1, then it will give x1 cube plus 2.
so suppose I have two elements in the domain. So suppose I have two elements in the domain, x1 and x2, which is in the domain of f. So suppose, so as I have mentioned here, there are two ways to show that a function is 1 to 1. So now we'll use this second condition. Okay, if f of x1 is equals to f of x2, that means x1 is equals to x2. This is also one of the conditions to check whether a function is 1 to 1 or not. Okay, so suppose f of x1 is equals to f of x2. That means what? So f of x1 is x1 cube plus 2, which is same as x2 cube plus 2, right? So I can cancel 2 from both the sides. So what I have?
x1 equal to x2.
x1 cube, which is equals to x2 cube. And I know if the cube of two numbers are same, then both the numbers are precisely same. That means x1
Equal to x2.
x2. So basically what I proved that if image of two elements are same, then both the elements are same. Okay, which basically we need to show to prove that f is a 1-1 function. Okay, so that means my function is
1,
1. Okay, so so the next function is, let's say, the square root function. So my first question is, so when I'm defining the square root function, what is the domain of this function?
Greater
than
equal to
0.
0.
Greater than 0. Greater equal to 0.
Greater equal to 0. Okay, so okay, so this is my function. This is my square root function, and I want to know whether this function is 1-1 or not. So what is the answer?
So it's 1-1.
Yeah,
One.
so yeah, yeah, so this is 1-1, and why?
So we can say proof in the same way we did for a cube.
As
for-
above.
Yeah, correct. Okay, so let's say I'm taking two elements, x1 and x2, which is in the domain of the function. Okay, suppose image of these two elements are same. That means square root of x1 and x2 are same. So here square root is always positive, right?
Yes, sir.
So I can't have negative square root. Okay. So so when I'm saying square root of x1 and square root of x2 are same, so if I take the square, then also they should be same, right? If a is equals to b, if square root of a is equal to square root of b, if I take their square, then they are also same. So similarly, if I take the square here, then what I will get? I'll get x1 is equals to
Next.
x2. Okay, so it's more or less easy. So that means my function is 1, 2. So another way to check this, so graphically, so there is one more way to check whether this function, whether a function is 1, 1 or not. So that is basically called horizontal line test. Okay, so suppose by somehow you know the graph of a function. Okay, suppose you know the graph of a function.
Excuse me, sir.
Yes.
Good morning, sir.
Huh.
In this session, what we are covering,
Hmm.
I'm asking what we are going to cover.
Okay, so so I have started from week 5, from the beginning of week 5. So I don't
Yes.
know. Yeah, so I don't know how far I can go. Okay, I'll try to go. Mostly, I'll try. At least I will try to cover week 5 and 6.
Okay. Okay, sir.
So suppose I have some graph of a function. Let's say this is the graph of a function. So this is my graph of a function. And from the graph, I want to know whether this, so this graph represents some function f. Okay. And from the graph, I want to check whether this function is a one-to-one function or not. Okay. So for that, what I have to check, I have to draw all the possible horizontal line. Okay. If one horizontal line crosses this graph of the function more than once, then I say that this function is not one.
Yes.
Okay. So suppose okay, just a minute. Okay, so suppose, so if I draw this horizontal line, let's say this horizontal line, then as you can see, this horizontal line actually doesn't passes through the graph of the function. Okay,
Yes.
so that means no problem, at least for this horizontal line. Okay.
But
Ex-
sir, here the function f is not defined. So how can we say?
Sorry,
that it
sorry.
is- Sir, actually here the function is not defined, right? Like there is no curve of the function here. So how can we say that it has? Here we can say that it is not a function,
Why?
because there is no curve crossing the horizontal line.
No, why? So I don't see like why this is not a function. Okay, it's fine. Like a horizontal line may not passes through that curve. Okay, that is
Sorry. It is not a 1-1, we can say, or a
yeah.
1-1.
Yes,
Right,
yes.
sir?
That is what we are going to check. Yeah.
Okay.
Okay. So let's say one more horizontal line. So if I draw this horizontal line,
Not 1-1.
so as you can see, this particular horizontal line, it passes through this given curve more than once, right? So here, one is here and another one is here. Okay. So basically what basically it's saying, so image of this function at this point, okay, and at this point, image of the function at x1 and x2, they are same. Okay, so when a horizontal line passes through this curve more than once, that basically saying I can have two different element x1 and x2, but their images are same. Okay, that means this function f is not 1. Okay, so similarly, if I try the same thing with the modulus function, okay, so here as you can see, so in case of modulus function, so this is the graph of the modulus function, right?
Yes,
So
sir.
so if I try to apply the same thing, if I draw a horizontal line, okay, so if I draw a horizontal line, then as you can see here, you have 2 points. This horizontal line crosses the graph of the function more than once.
Yes,
Okay.
sir.
So this is precisely saying that you have two elements in the domain and image of these two elements, they are same. Okay, that means this function cannot be 1. Okay. And similarly, if I take, let's say,
Sir, I have a doubt. Like, can we say in the above graph? Can you please show?
which one? This one.
Yes.
Uh,
At the vertex point, if we pass the horizontal line, then can we say that that point is a 1, 1?
No, what do you mean by at that point it is 1, 1? So
Like at a vertex, it is 1, 1, right?
no, what do you mean by at a vertex it is 1, 1? So
I think the maximum, I mean the local minimums are the value, the
The,
curve ends not.
then
So if
asking
we draw
question for
line at that line.
no.
domain.
Just let me complete. Okay, so let me complete. So the thing is, so at a particular point you don't have any one, so you don't check oneness and non-two-ness of a function. Okay, you have to check it throughout the domain. Okay, so what do you mean by that? If at a vertex the function is 1, 1, that has no meaning. Okay, so you have to check it throughout its domain. Okay, that's why you have to consider all possible horizontal line. Okay, we are not taking a particular horizontal line and we are not checking for it. Okay, we are checking that all the horizontal line passes, if all the horizontal line passes through the curve at most 1, then we can say that this function is 1, 1. Okay, if you can find one horizontal line which crosses the graph of the function more than once, then you say that the function is not 1 to 1. Okay, so when you are saying that this particular horizontal line crosses this graph of the function at one point, then you have to go for some other horizontal line and you have to check it for all the horizontal line. Just by checking one horizontal line, from there you cannot conclude that this function is not 1, 1. Or whether this function is from there you cannot conclude that this function is 1, 1. Okay, you have to check it for all the horizontal line. Okay, all the horizontal line you have to check, and you have to see whether all the horizontal line crosses this graph at most one point or not. If all the horizontal line crosses the graph at most one point, then you say that this function is 1, 1. Otherwise the function is not 1. Okay.
Sir,
Yes.
I have one more doubt, sir. In root x, so for f of 2 we have 4, and again for f of minus 2 we have 4. So it points the same output. So how would it be 1 to 1, sir?
Which one?
For different values we have same output.
Can you repeat? This is my root function, right?
Yes, sir. For example, suppose if root 2 we have the same value, and for root minus 2 also we have the same value.
No,
we
so
don't have
you are
minus.
saying f of 2
Yeah, it's equal to 4.
It's
Root 2.
it's root 2.
Root 2.
Yes.
sir.
Hmm.
And for f of -2?
Not defined. It is complex.
So f
Under
of
root
minus 2
2
is what?
not
Minus
defined.
of,
It is
So
complex
we
number.
don't have okay.
this is a complex number. Okay, this
Okay,
is
so then we have different output, no, sir?
This is a
Even
2.
if it is a complex number, we have a different output.
yeah, fine. This is a different output. So what is your point? So
Sorry.
okay.
So I thought it's same output. So
No,
how
no,
it
no.
can be 1 to 1?
No,
So
no,
it is
no.
different output.
So
Okay, sir.
first thing is this is a different output, and second thing
Okay.
is we are not dealing with complex number. Okay. So
Yes, sir, yes, sir.
as you can see, my domain consists of only positive real numbers. Okay. So that's why
Okay,
this
sir.
-2. Okay, -2 is not in the domain of this function.
Yes, sir,
Okay.
yes, sir.
Since if I'm taking -2, I'm getting something outside of real. Okay, I'm getting a complex number. So that's why I'm excluding all the negative numbers. Okay, so that I will get a real valued function. Okay, if I consider the negative numbers, then I will get a complex valued function, and I don't want a complex value function. Okay, I want a real value function. That's why I'm considering all the positive real number. Okay, if I take the square root of a positive real number, then I will always get a positive. I will get a real number, or say positive real number. So if I take negative number, then I will get a complex number, and that
Yes, sir.
I don't want. Okay.
Yes, sir, we don't want, but basically the definition is we shouldn't get the same output, right, sir, for one-to-one function.
Yes.
So here the output is different. That's why we conclude as is one-to-one.
So again, I'm saying that we are not considering the negative numbers. Okay. So once you consider the negative numbers, then you are in trouble. Trouble in the sense you land in complex number. Okay, that is what we don't want.
Okay, sir.
So again, even without considering the complex number, still this function is one to one. Okay, and that is a different fact. If you consider complex number, that is a different issue. So there will be a lot of issue. Okay, so then you have this square root function. Actually, you have multiple things. Okay, so it's better not to go towards the negative number.
Okay, sir.
Okay, so so the next let's say this function. So let's say graph. Take a graph of some. So this is my function. So this is a graph of some function f. So now if I try to draw the horizontal line, so if I draw this horizontal line, as you can see, this horizontal line passes through this graph at one point. Okay, and similarly, if I draw one more horizontal line, same thing happens. And so here also it passes through one point. Okay, so all the horizontal line, as you can see, it crosses the graph of the function at most one point, right? So if I draw any horizontal line, it passes through the graph of the function at most one point. That means this function one to one. Clear, like how we are actually using this horizontal line test to check whether a function is one to one or not. Obviously, first we should have a graph of the function, then only we can apply this horizontal line test and vertical line. Okay, so okay, so now we have, suppose, so the next thing is, suppose we have a one-to-one okay, so there are few special type of one-to-one function. Okay, so before that we'll talk about some class of one-to-one function. Like using that, we can actually generate lot of one-to-one function. Okay. So these class are basically strictly increasing function and strictly decreasing function. Okay. So let's say, suppose I have a function a to b, and I can say this f is a strictly increasing function. F is a strictly increasing function if I take two elements in the domain of the function, okay, such that x1 is less than x2. Okay, so if two inputs x1 and x2, and with the condition that x1 is less than x2, then this should implies that f of x1 is strictly less than f of x2. That means, as you can see, f actually preserve the order. Okay, if I take two element x1 which is less than x2, then f of x1 is also strictly less than f of x2. That basically implies this f actually preserve this order. Okay, so if I take two element x1 and x2, and if they whatever order they have, f of x1 and f of x2 have also the same order. Okay. And the second class is, so one class is strictly increasing function, and the second class is strictly decreasing function. Okay, so a map a to b decreasing. So a map is strictly decreasing if it reverses the order. Okay, so what does it mean? If x1 is
X1
less,
is greater than x2, so
no, it will reverse the order. Okay, what? So it will reverse the order here. Okay, so if
so f of x1.
yeah, so if x1 is less than x2, this should imply that f of x2 is less than f of x. So as you can see, basically it reverses the order. Okay, it reverses the order. Okay, so if I take two elements in the domain and x1 is less than x2, then f of x2 is less than f of x1. Okay, it changes the order of the elements in the domain. Okay, so you have two class of function. One is strictly increasing and another one is strictly decreasing. And strictly increasing, they preserve the order. Okay, so strictly increasing function, they always preserve the order, and strictly decreasing function, they change the order. Okay, so so one note that if f is a strictly increasing or strictly decreasing function, then f is an one-to-one. Okay. So, so if it's basically it's saying all the strictly increasing function and all the strictly decreasing function, they are one to one. So it's clear, right? If basically it's saying what? So it's pretty easy to prove that this strictly increasing function are one function. What basically it's saying? It's saying that if x1 is less than x2, then f of x1 is less than f of x2. So this is basically, you can show that if x1 is not equal to x2, that means f of x1 is also not equals to f of x2, right? Because if I take two element x1 and x2 and they are not equal, that means either x1 is less than x2 or x2 is less than x1. Okay. So if I take their image, so then f should preserve that order. That means f of x1 can never be equal to f of x2. Okay. So that means all the strictly increasing function, they are one function, and all the strictly decreasing function, they are also one function. Okay.
So, one thing just.
Yes.
If function is not strictly only increasing or decreasing, in that scenario also one to one, yeah.
Okay. So the thing is, it's depend how you are defining it. What is the definition of increasing function?
Okay.
Sorry.
Okay. Just saying. Okay, got it.
Yeah. So it's depend on your definition. Like so, if you see actually in the lectures are whatever definitions are gave for increasing function, I'm actually writing it as strictly increasing function. Okay. So if you go back and check the lecture, so if you see that whatever definitions are is giving for increasing function, I'm writing the increasing function as strictly increasing function. Okay. And similarly for whatever sir has written for decreasing function, I'm writing it as strictly increasing function. Okay.
Yes.
So yeah, so basically that's why it can create a confusion, but remember that this okay, so more or less this actually for this is the most favorable word for this function.
Okay.
Okay, so let's take few examples. Suppose you take this one, R to R. So my question is, can I say anything about this f, whether this function is a strictly increasing function or a strictly decreasing function, or neither of them? Neither of them. Why?
Strictly increasing, sir,
Increasing function, sir.
because x is always less than x square.
F of minus
So one thing I said, okay, if you remember, one thing I said, if a function is either strictly increasing or strictly decreasing, then it is always 1. Okay, that is what I have written here, right?
Yes, sir.
If a function is strictly increasing function, then f is always 1 to 1, right? So so if this function, that whatever x goes to x square, if it is a strictly increasing function or strictly decreasing function, then it has to be a 1 function, right? Right or not?
Yes, correct, sir.
Yes, but it fails the horizontal test.
But we know this is not one to one, right?
Yes, sir.
That means it cannot be strictly increasing, or also it cannot be strictly decreasing. Okay, so it is neither of them.
Yes, sir.
So this is a easy way to check whether a function is strictly increasing or strictly increasing or strictly decreasing or not. So
Sir, but
not,
it satisfies the condition, no, sir, for strictly increasing. X
No,
is always less than x2.
no, it certainly it will not satisfy the condition. Okay, so let's say, for example, let's say this one. So -5 is less than 1, right?
Yes, sir.
So -5, this is x1,
This
is x2, right?
x2. Yes, sir.
Then if I take f of x1, what is f of x1?
25.
Okay, 25.
25, right? That means
Okay.
it is less than f of
X.
x2, right? This is, which is 1, right? So from here I can say that this function is not strictly increasing, right?
Yes, sir.
Yes,
Got
sir.
it.
Yes, sir.
Okay, from here I can, because it's not preserving the order. It actually, it's, if you see for this pair of element, it's changing the order, right? It's changing the, flipping the order. Okay, so from here I can say that this one not a strictly increasing function. Okay. Now next I have to show that it is also not a strictly decreasing function. So again the same thing, if I take -2, this is less than 2, right? Let's don't take 2, let's say this is less than 1, not 1, let's say, right? But if I take their image, what I'm getting f of -2 is 4, which is less than
F of 3, 9.
9.
So again, if you see this f, it actually preserves the order, right? It preserves the order. That means
Yes, sir.
Yes.
F of 2 is less than F of 3.
it's not a strictly
Strictly decreasing function.
decreasing function. So that means this function is neither strictly increasing nor strictly decreasing. Okay, and as I said, it's pretty easy if you use this statement. Okay, this statement says if f is a strictly increasing or strictly decreasing function, then it says f is always 1-to-1 map. Okay, in this case, as you can see, this function f is not 1-to-1 map. Okay, since this is not 1-to-1 map, this cannot be a strictly decreasing or it cannot be a strictly increasing function. Okay, let's say take maybe say one more example. Any idea? Oh, what about this one?
Same, sir.
Neither.
Neither
Increasing, neither decreasing.
same logic you can use, that this function is not 1-1, right? So since this is not 1-1, it cannot be a strictly increasing function, and as well as it cannot be strictly decreasing function. Okay. What about this function?
Yes, sir. This is increasing if x is increase.
Yes, sir. Increasing.
Yeah, if x is decreased, this is this thing is decreased.
Correct. So this, now it's pretty easy to tell that this function is not this function is actually increasing function. Okay, so even if you draw the graph also, you can see that this is a increasing function, like 1 plus x. So at x equal to 0, this graph should look like this. Okay. So if I take x1, let's say this is my x1. So image of x1 is this f of x1. And if I take x2, which is greater than x1, then as you can see, this f of x2, if x1 is less than x2, that means f of x1 is also less than f of x2. Okay, so as you can see, this f preserve the order. Okay, so you can see it from the graph. Like if you take some element, so here, so this image is less than the image of x2. Okay, so we can prove it mathematically. If x1 is less than x2, if we add 1 on both the sides, what I will get? 1 plus x1 is less than 1 plus x2, and this is nothing but f of x1, and this is nothing but f of x2. Okay, so this is basically it's saying if x1 is less than x2, then f of x1 is also less than f of x2. That means f is a strictly increasing function, right? And since f is a strictly increasing function, after that I can blindly say that this is a 1-1 function. Okay. Okay, so so any doubt from this 1-1 function and strictly increasing function?
Sir,
Or
Sir, one
so
example.
we can say that all even functions are even functions are not 1-to-1, and odd function are 1-to-1 because they cross the x line, increasing or decreasing. Like
saying,
x is cube. If fx equal to x or x is cube or x to the 5, these all are 1-to-1. And x square, x is 4, these all terms are not 1-to-1.
It will be in a restricted domain.
Yeah, it's actually it's depend on how you are defining your function.
Domain.
Yeah, so if you so for example, if you consider this function from
Real to real.
in case of real to real, like all these functions are actually this x square and x4, these are all not 1-1 function.
Not 1-1 function.
Yeah, so and whereas this odd power things are there, xq, x5, these are all 1-1 function. Okay.
That's the math.
Yeah, so but okay, if you restrict your domain,
R
like
to R. Yes.
yeah, for maybe say if you take from so in this case this is a 1-1.
Yes, this is 1-1 function.
So even, so what is the definition of even function? So if you are considering from R to R, okay, suppose you have a map from R to R, right?
Yes.
So it's basically saying f of x is equal to correct?
Yes.
Yeah, so in this case, so if a function satisfies this condition, okay, then certainly it cannot be
1-to-1.
because what basically it's saying f of 2
output are same
and f of minus 2
both are
same. Okay.
Yes.
But you cannot say anything about this you cannot say anything about this odd function. Okay, so odd function, you cannot say that a odd function is always 1 to 1. That you can't. Okay.
Sir, can you please go to that example, sir?
Yeah, I'll come to that. So one thing, like whoever asked this question, so one thing you can always say that a even function cannot be 1 to 1. Okay, but you cannot say that a odd function is always 1 to 1. Okay, so for a so no, in the case of xq and x5, they are maybe 1 to 1. Okay, but you can have some if you try to maybe let's say draw the graph of the function, then you can have some drastic graph where this function is odd, but it is not a 1-1 function. Okay, so you
Give
try
an
to
example for that, sir. Not able to get that.
no. What I am saying that so what I am saying, if f is a odd function, that doesn't imply that f is not 1 to 1 because of the property, I guess. Because what basically it's saying, f of minus x is nothing but minus of f of x, right?
Yes.
That is the property. So from this property, actually, you cannot conclude anything. Okay. So I need to think about an example. Okay, but from this property, okay, you cannot conclude anything. Can you prove that using this property that f is 1? Can you prove it?
No, but the graph of x cube,
No, you are
x5.
taking actually. So the problem is you are taking some specific example of odd function, and so using that you are saying a huge statement. So I guess okay, I guess that this is not enough. Okay, so
Okay.
I guess you need to you still can have a odd function which is not 1 to 1. Okay, you need to define it properly, but my guess is if a function is odd, that doesn't imply that it is not 1. Okay. That doesn't imply that f is 1. Okay. Okay, so yeah, so which example? Someone asked me some example.
Yes, sir, that's that one's a strictly increasing function. This one.
This one.
With this example, sir. Yes, sir. Can you substitute some values and show me, sir? For f of x1 and f of x2, sir.
No, which so what value you want? Okay, let's say like f of 2, right?
Yes, sir.
What is the value of f of 2?
3, no, sir. 1 plus 2. And for another value f of minus 2, if we take, I mean, I'm considering x1 as 2 and x2 as some other different value.
Yeah, let's say 5, right?
Yes, sir. Yes, sir.
So f of 5 is what? 6, right?
Yes,
so
sir,
they preserve the order, right? They preserve the order, right?
Suppose if we take 2 and minus 2, sir, and if x2 is minus 2.
2?
Instead of 5, if we take f2 is minus 2.
You can't take minus 2, right? Because you have a condition that x1 is less than x2. Okay, minus 2 is not less than sorry, 2 is not less than minus 2.
Minus
right?
2, yes.
So you cannot take.
Okay.
Yeah, you can't take x to be minus 2. Okay, you have
so
to
for
take,
all the increasing and decreasing functions, we shouldn't take the minus values.
no, that is not correct. So if you are taking here x, so you can take that, you can take x1 to be minus 2, okay, x2 to be 2.
2, like vice versa, we have to take this.
No, some condition is given, right? x1 is less than x2, right? That is given, right? X. So I have, so in the beginning I have assumed something that x1 is less than x2. Okay, but when you are saying that x1 is 2, and x2 is -2,
Yeah, it is not
then-
satisfying that condition.
then this is not true, right? So
Yeah.
you can take negative number, but at the same time you have to make sure that whatever condition you are assuming, both the numbers should satisfy that condition, right?
Okay, sir.
Yeah.
So suppose if it is decreasing, strictly decreasing, then it is 1 to 1, sir? No.
Yeah, if it is, again, like
If
I
it
have,
is.
yeah, so I have mentioned it here, right? If a function is strictly increasing or
Increasing,
strictly
okay, okay, sir.
decreasing, then it's always 1, 2. Okay,
Thank you, sir.
thanks. Okay, so okay, so the next thing is exponential function. So we'll discuss about this exponential. Okay, so suppose I have suppose I have a number a is always greater than 0. And r is a real number. Okay, so the thing is, why actually we are assuming here a is always greater than 0, because if I take, say, a equal to -1 and r is equal to half, then if we take -1 to the power half, then I will get complex number, right? This is a complex number, right?
Yes,
Yes.
complex term.
So when we are taking this exponential, okay, a power r, I want this exponential to be a real number. So that's why we are putting this condition a to be greater than 0. Okay. So my first question is, suppose a is a real number which is greater than 1. Okay. So what are the possible value of a power r? So if r varies over
0
Or
to
positive,
infinity, sir. 1 to
0
infinity.
to infinity, all positive
0
numbers.
not.
All positive numbers.
yes,
Sir,
correct, all positive numbers. Okay, so it cannot be 0, right? It cannot be
Yes,
0
cannot be
and
0.
it cannot be negative. So a power r is basically in between. Whatever value it will give, certainly it will lie in this interval. Okay. And what about if r is positive? If r is positive, r is, let's say, not positive, let's say r is greater than equal to 0, then what are the possible value a power r can take?
1 to infinity. 1 to infinity.
Correct. So
1 to
because, okay, so the condition is also given, a is also greater than 1. Okay, so we are doing all the things, whatever now we are doing with the condition that a is greater than 1. Okay, so if a is greater than 1 and r is greater than equal to 0, then a power r is always in between 1 to infinity. And if r is less than 0, then a power r is always
0 to 1.
correct. 0 to 1. Okay. So so the next thing is, if a is less than 1. Okay, so if a is less than 1, then what are the possible values of a power r?
0 to infinity.
Correct. 0 to, it's always in between 0 to infinity. And what about if, again, I'm imposing one more condition. What about if r is greater than or equal to 0?
0 to 1.
It's always a power r is always in between 0 to 1. Because if I take r to be 0, then if r is 0,
Then 1.
then basically it's 1. So that's why I'm writing a with a closed bracket. Okay, because it can take 1. Okay.
If a is greater than 0, less than 1, right?
A
this
is
case.
greater, yeah, correct. A is always greater than 0. So that is the first condition. Okay. A is always greater than 0.
Thanks, sir.
So, so the next condition is, what about if r is less than 0?
1 to infinity.
Correct. It's basically 1 to infinity. Because see, if a is less than 1, a power r, so r is basically here, r is positive, sorry, negative. So 1 by a to the power minus r. Okay. So this is now, so since r is negative, minus r is positive, and a power minus r is less than 1 and greater than 0. That means 1 by a to the power minus r is always greater than 1. Okay. So these are the thing you should always careful, like, wow. So if I change the values of a, then a power r actually changes in between this mainly this interval 0 to 1 and 1 to infinity. Okay. So these are the basic thing you need to know, like if I change the values of a and change the values of r, how a power r will behave. Okay. And there are few properties of exponent. So one property is a power s times a power t so
S
as you
plus
can
t.
yeah, s plus 2, as you can see, the like, so one of the crucial thing about this exponent is it's basically it converts a multiplication to a addition. Okay, so when I'm multiplying two things, a power s and a power t, what I am getting, a power s plus. So basically it's convert a multiplication to a addition. Okay, so that's why it's quite crucial. Okay. And the second condition is a power s power t is nothing but a power st. And the third one is a b power s is nothing but a power s times b power s. Okay. So these are the property of exponent. So let's define exponential function. Sorry. So the next thing is, so I have, so a function f is an exponential function. if f of x is a power x for some a greater than 0 and a is not equal to 1. Okay, if I have a function which is in this form, f of x is equal to a power x, then I say that, and with some condition on a, then I can say that this my function is an exponential function. So for example, if I take f of x is equal to 2 power x, so this is a exponential function by the definition, right? This is a exponential function. If I take f of x is equal to, let's say, 0.5 power x, then this is also a exponential function. Okay, if I have some number which is greater than 0 and not equal to 1, and if I am taking that power x, okay, so this is a exponential function. Okay, so then what is the domain of this exponential function?
Real numbers.
Correct. So exponential function is basically, it's a map from R to R. So the domain is all real numbers. Okay. So so as you can see, there are two basically there are two range in some sense. There is a one breaking point for a, that is a cannot be 1. Okay, so there is a breaking point for a. So a is basically in this interval. Either a is in this interval or a is in this interval. So if a is in between 1 to infinity, then the graph, if I try to draw the graph of this function, okay, so then it will look like this. Okay, so this is the graph of f of x is equal to a power x if a is in between 1 to infinity. As you can see, if I try to apply this horizontal line test, then this function is a 1, 1 function. Right? This is always a 1, 1 function. If a is in this interval 1 to infinity, then this is the graph of this exponential function, and this function is always 1, 1. And similarly, if we try to draw, if we take a to be in this interval, then what will be the graph of this function f of x is equal to a power x? Any idea how we can draw the graph of this function if a is in this interval 0 to 1?
Reverse.
The opposite one, sir.
Yes, sir.
Mirror image across y-axis.
So at 0, it's 1, right? And if I increase the value, if the value of x
tending to 0
will increase, then this graph will
tend to 0.
And if the value of x is negative, it will
increasing.
So in that case, if a is in between 0 to 1, then this is the graph of this exponential function. And similarly, you can check that this is also a 1, 1 function. Okay. So these are also the examples of 1, 1 function. Okay. Okay, so the next thing is, so we'll come to, like, when we'll discuss this inverse function, then actually we'll discuss the inverse of this exponential function, which is actually important for this course. So the inverse of this exponential function is basically the logarithm function. Okay, so let's quickly recall what is composition of two function. Can one of you tell me what is how we define the composition of two functions?
It will be f of gx and g of fx.
No, suppose I have two functions f and g.
Codomain of one function is domain of another.
No, how we define the composition f circle g? How we define? What is the definition of this?
So replace x in fx by gx.
Correct. So this is nothing but f of
gx.
gx. Okay. So for example, if I take f, so suppose f is a map from R to R, and x goes to x square plus 1, and g is a map from R to R, and g x is x minus 1, then how we can compute, then what will be the value of f compose g of x?
So gx square plus 1 and gx is replaced by x minus 1 ka whole square plus 1.
Correct. So what is this? This is basically g of x. Okay, and what
Plus
is
one.
what is g of x? G of
X
x
minus
is
one.
x minus 1, and which is nothing but f of x minus 1. And what is f of x minus 1? This is x minus 1 whole square
plus
plus
1.
1. Okay, so this is how we compute the composition of function. Okay, and so one of the most crucial thing about the composition function is calculating the domain of the composition function. Okay, so the for example, if you see actually how this composition of function behaves. So suppose, so you have x, right? So you have x, this x goes to g of x, right? So that means this x should be an element in the domain of g, right? Correct.
Yes.
And
Yes, sir.
again this g should go to f of g of x. So again we are taking f of g of x. That means f of, so that means g of x also should be an element in the domain of f, right? Because we are taking f of g of x. If g of x is not an element in the domain of f, then we cannot write this. Okay, so basically when we are taking composition of function, we have to make sure that this x satisfy two conditions. Okay, so I can say that x is in the domain of f circle g if this x satisfy two conditions. So what are these conditions? The first condition is x is in the domain of g, and the second condition is g of x is in the domain of f. Okay, these are two things you need to check to know whether x is in the domain of f circle g. So the first condition is x is in the domain of g, and the second condition is g of x is in the domain of f. Okay, you have to make sure. So when you are checking, when you are computing the domain of some function, domain of this composition function, you have to make sure that this x satisfy both these two conditions. Okay.
G of x is in domain of FOG, right?
No. G of how come G of x can be in the domain of FOG?
So it is the input of FOG, right?
No, see, when I am writing FOG, that is x, right? X is in the domain. So I'm trying. So in this case, I'm trying to compute the domain of FOG, right? So to compute the domain of FOG, okay. So how we defined FOG? This is nothing but f of g of x, right? So when I can say that x is in the domain of FOG, the first thing is g of x should be defined, right?
Yes.
That means x is in the domain of G.
Yeah.
Correct. The second thing is f of g of x should also define, right?
Yeah.
That means g of x is in the domain of f. Okay, we have to check two conditions. Okay, so here actually we are computing the domain of FOG. Okay, we don't know the domain of FOG. Okay, and how we are computing? We are computing using the definition, how we define FOG. Okay, we have defined FOG using this rule. Okay, so the first thing, that g of x, it basically tells that x is in the domain of G, and the next thing, which is f of g of x, it basically tells you that g of x should also in the domain of f. Okay, so these two conditions you have to make sure that if x satisfy both these two conditions, then you say that x is in the domain of FOG. Okay, so let's take this example. So what is the domain of F here?
Not equal to 1. Always not equal to 1.
So domain of F is all real number except 1, right?
Yes, sir.
And what is the domain of G?
Sir, all real
All
except
real
0.
number except 0.
Correct. So while calculating the domain of F circle G, so when I can say that x, when I can say that x is in the domain of FOG, if x satisfy both these two conditions. Okay, x is in the domain of G and g of x is in the domain of F. Okay. So the first thing is x is in the domain of G. Okay, so if I take any number, correct? If I pick any number in from this set, that is a element of domain of G, correct?
Yes, sir.
But the second thing, I have to make sure that whatever x I am picking, that should be in the element in the domain of F. Okay, so is it true if I take any element from this set that is that element is that if I take the second condition, if I take any element from this set, is it true that is it true?
No, sir.
Why?
Because one is not satisfying the domain F.
Correct.
So we have to exclude one also.
No, we have to exclude
When putting the value of one.
Yeah, we have to exclude such x such that g of x equal to
100.
1.
3.
Yes.
1, not 3, I guess.
One.
Because 1,
Yes,
see,
one, sir.
1 is not in the domain of x. Okay, so we have to exclude such x such that g of x is equals to 1. Okay, so when g of x can be 1? G of x is what? 3 by x, which is 1. That means x
Yes.
equal to
3.
Okay. So basically we have to exclude 3 from this set, right? So that means the domain of -0 and 3. Okay, so this is the domain of F compose G. Okay. So the next thing is inverse function. Okay, so since we have defined this composition function, so once we have composition function, definition of composition function, in after that we can define the inverse function, because inverse, so we need this composition, the definition of composition to define this inverse of a function. Okay. So let's say, suppose f is an 1-to-1 function. So this is the first condition. Okay, I can only talk about inverse of a function if that function is 1-to-1. Otherwise, I cannot talk about inverse of a function. So suppose f is a 1-to-1 function, then the inverse of the function f is a function f inverse such that it should satisfy two conditions. What are these conditions? What inverse of a function should satisfy?
It has to 1-to-1.
F
No.
of gx is equal to f of gx equal to x.
Correct. So if I compose f with f inverse, then I should get identity function, right? So the first condition is f inverse
X is equal to x.
x for all
G
x
inverse.
in the domain of f, right? Correct. And what
Yes,
is
sir.
and domain of f is same as range of f inverse. And the second condition is this is x for all x in the range of f, which is same as domain of f inverse. See, if I have a map f from A to B, so this is the domain, right? And this is the codomain. So if f is a map from A to B, then f inverse will be a map from B to A, right?
Yes.
So then the codomain, so not codomain, it's better to write the range. So here you can assume that this range of f and codomain of f, they are same. Okay. So what basically f inverse does, so now the range of f is basically the same of domain of F inverse. Okay. And the domain of F is same as the range of F inverse. So that is what I have written here. So when I am writing F inverse of F of X, so what I am doing, I'm taking, so in this bracket, if you see, first I am taking F of X, right? So when I can write F of X, if X is in the domain of F, right? And I know that domain of F, I know that domain of F is nothing but the range of F inverse. That is what I've written. Okay, so X is in the domain of F, and domain of F is nothing but range of F inverse. And similarly, the second condition says F of F inverse of X. So as you can see inside here, I have written F inverse of X. So when I can write F inverse of X, okay, if X is in the domain of F inverse, right? So if X is in the domain of F inverse, and domain of F inverse is nothing but the range of F. Okay. If I have a function F inverse such that F inverse satisfy these two conditions, then I can say that F inverse is a inverse of F. Okay. So any doubt with the definition of F inverse? How actually I'm writing this X is basically in
No
this
doubt, sir, but better with some examples, sir.
Yeah, okay. Okay, just a minute. So suppose you take this function 1 by so my first question is whether this function is one to one or not.
1 to 1.
Yes, sir.
Why this is 1 to 1?
It is strictly increasing or decreasing, not neither.
Yeah, correct. how you will prove it that it is not
So first way, it take fx1 equal to fx2, and second is by making the graph.
Okay. Suppose f of x1
Equal
is
to fx2.
f of x2. Suppose f of x1 equal to f of x2. That means what? 1 by
x1 minus 11 equal to,
right?
yes,
So if I take the reciprocal, what I will get? I'll get x1 minus 11 is same as x2 minus 11, right?
right,
That means x1 is equals to
x2.
x2. Okay, so that means my function, whatever I have written here, this is a 1 1 function. So this is a 1 1 function from R to R. Okay. And what I want to compute the inverse of this function, right? I want a map F inverse which satisfy these two conditions, that if I compose F inverse with F, I should get identity map. Suppose I have a map F inverse and F inverse of X is some number Y. Okay. So I want a map F inverse which satisfy these two conditions. So the first condition is f of F inverse equal to x, and one more condition is f of F inverse of x is x, right? So we don't need this one. From this condition we can get what is F inverse of x. So what is F inverse of x? So if I try to compute the left hand side of this expression, what I will get? What is F inverse of x? What is this thing?
Y.
Because that is what I have written here, right? F inverse, I'm representing, I'm using some symbol just to represent F inverse of x. So this is
Fy equal to x.
f of y equal to x. And what is f of y? F of y is
F inverse x.
no, f of y is what? I have a map, right? F of x. What is f of y?
Yes.
1 by y minus 11, right?
Yes, sir. Yes, sir.
Which is
X.
x. So what basically I want to compute f inverse of
Y.
x,
Yes.
I need to compute the value of y, right?
Y.
So if I multiply y by 11, then what I will get? I'll get 1 by x
Plus 11.
is equals to y minus 11, and which
Y
is same as y equal to 11 plus
1 by x.
1 by x. Okay. So f inverse of x is nothing but 11 plus 1 by x, right? So first what we, so initially this is this was given that f of x is equal to 1 by
X minus 11.
x minus 11, and what we have computed, we have
F inverse
computed f inverse of x,
11 plus 1 by x.
which is nothing but 11 plus 1 by
1
x.
by x.
And to make sure that our f inverse of x is correct, what we need to do, we need to compose both the functions. This is nothing but f of 11 plus
1 by x.
1 by x, which is 1 by 11
Plus 1 by x.
x minus 11,
11.
which is x, right? Because this and this will get cancelled, and 1 by x is x. And similarly,
F inverse of fx.
is f inverse of 1 by
X minus 11.
11, which is nothing but 11
Plus
1 by
1 by x minus 11.
which is nothing but 11 plus x minus 11, which is x. As you can see, whatever map we get, that satisfy both these two conditions. Okay, condition 1 and
1
condition
and
2. Okay, so that's why this is a inverse function. Okay. Okay, so let's go to this logarithm function, because once we have inverse of a function, then we can easily define logarithm function. So so previously we had this exponential map.
Sir, one thing. F and f of inverse x is not equal to f of inverse f of x. That means it is not a one-to-one function. Can I conclude it, right?
Sorry.
F of inverse x,
Hmm.
f of inverse f of x is not equal. That means it is not a one-to-one function. Like here expression.
No, here no. If you want to talk about f inverse of a function, then the first thing you need to check that that function is 1, 1. Okay. If it is not 1, 1, then in the first step itself we cannot talk about inverse of that function. Okay, we can only talk about inverse of a function if that function is 1, 1.
Okay, got it. So,
Yeah. Okay, so okay, so the next thing is this exponential map. Okay, so so this is a exponential map, and with the condition that a is not equal to 0, a is greater than 0, and one more condition is there. What is that?
Not equal to 1.
A is not equal to 1. Okay, so this is a 1-1 map. So this exponential map is basically it's a 1-1 map from the set of real number to 0, infinity. Okay, this is a 1-1 map with, and the domain of this map is set of real numbers, and the codomain of the range of the map is 0, infinity. So logarithm map. So so the logarithm map is nothing but it's a inverse of the exponential map. Okay, so logarithm map is nothing but it's an inverse of the above map. Okay, so log base a. Okay, so the log base a is a map from 0, infinity to r.
Real.
As I said, so in this case, as I said, so the domain of f and f inverse, they get interchanged, right? So here, as you can see, the domain of f is r and range of f is 0, infinity. So since log is a inverse of f, that's why the domain of log it becomes 0, infinity, and the range of log it becomes set of real. So this one and this one, they get interchanged. Okay, so log is nothing but it's a map from 0, infinity to r. So x goes to log a, right? So so when I write y equal to log of x, right? So what does it mean? That means the image of x basically goes to y, right? X basically goes to this statement, whatever I have written here, that basically means the
Log
image.
x, basically.
Yeah, so this is same as
The a to the power y
is
x.
x.
Equal to x.
X. So this statement, whatever I have written here, I'm not writing in the air. Okay, that this statement I can write because of the fact that this exponential, this is a power x, it's the inverse of this function. That's why I can write this. Okay, it's not that I am writing in something in air. Just because this previous map, whatever map I have defined here, this is a inverse of this map by definition. That's why I can write this thing. Okay, and and if I try to draw the graph of logarithm function, what is the graph? If suppose a is less than 0, sorry, greater than 0 and less than 1, what will be the graph of
vertically asymptote, and then it will increase above the x-axis.
vertically?
Asymptote.
Yes, because see the inverse. So we have already saw the graph of this this f of x is equal to a power x, right? When a is in between 0 to 1. Okay. So logarithm function will be the logarithm function is basically inverse of this function, right?
Yes.
So then this will basically the reflection of this graph with respect to y equal to x axis, right? Sorry, y equal to x line. So in that case, the graph will be something like this, right? And it's clear from the graph that this function is 1, 1 function. Okay, and the domain of the function is 0, infinity, and the range of the function is r. And similarly, if a is greater than 1,
reflection about x-axis.
correct, correct. So then you will get this graph. Okay, it's basically it's increasing. It's an increasing graph. So this is increasing function, and whereas this is decreasing. Okay, so in this case, this graph is in. So this is decreasing when a is in between 0 to 1, and when a is greater than 1, it's increasing. Okay. So
x-axis intercept is 1, 0 in both cases.
Yes, in both the cases, the x intercept is basically 1, 0. Also 1, 0. So so there are few. Okay, so one of the most crucial thing is this property. Okay, so half of the problem you can solve in for logarithm. Half of the problem you can solve using this property. Okay, and there are few other properties of logarithm. So the first property is so as you can see in some sense, exponent, if you see the exponent, the property, one of the property of exponent, it basically converts your multiplication to addition. And similarly, if you see logarithm, it also converts a multiplication. So if a multiplication, it converts
addition
to addition. Okay. And
log m base a minus,
correct, log m minus
log n base a.
base. Okay, and what is this? This is log
minus of log n
log
base
1 minus
log n base a. Log 1 is 0.
So this is 0.
Is minus log n base a.
Correct. So and the last property is nothing but I can take this. I can
Yes, sir.
so this is nothing but
R
r times
log m base a.
is a. Okay. So so the last property, and which is quite useful,
Base change.
change of base formula. Okay. So what basically it says, log x base a, I can write as log
Sir, x by log a.
no, so sorry, I can't understand
Sir,
what.
it will be right as a log x upon log a, and base is something like n.
Some let's say m.
Yes, sir. Divided by log a base m.
Okay. So this is quite useful. Like suppose you have log 2 3, you can write it as log 3 base 5 log 2 base 5, and the same thing also you can write it as log 3 base, let's say 10 divided by log 10 base 2. Okay. And you can change this, you can change the base as far as your choice. Okay. So one of the crucial thing about this log base log changes, you can change this a to your convenient number, and so according to that you can do your calculation. Okay, so this is so this property, this change of base formula, and this one, the first one. Okay, these two things, using these two property, you can solve most of the problem in logarithm. Okay. Okay, so the next thing is, if you have some doubt, then we can start solving all these questions, like related to week 5, 6, 7, 8, whatever you have. Any doubt?
If a is between 0 to 1, these properties are false.
Yes, it doesn't matter what is the value of a. Okay, if a satisfy this condition, okay, so if a satisfy this condition,
Yes,
this
sir.
two condition, then all this property holds.
Okay, sir. Thank you.
Okay, so there is only one restriction, that a is greater than 0 and a is not equal to 1. Okay, any other doubt? Any doubt from let's say activity or practice
Sir,
assignment?
can you take one more example of inverse function?
Do you have anything on your mind?
No, sir.
Okay. Let me take. So this is, suppose this is a function f of x, right? So the first condition, first thing is whether this function is 1, 1.
Yes, sir. It is on 1.
Correct. So if you see, like if you take suppose f of
x1 equal to f of x.
x2, then
x1 cube minus 5 equal to x2 cube minus 5. 5 get cancelled.
that means we have
x1
x1
equal to
x1 cube,
x2
which
cube.
is cube.
x1 equal to x2.
Correct. So now suppose this, so since this function is 1, suppose this function has a inverse, right? So let's say f inverse is a map from R to R, and f inverse of x is y. So the main thing is we need to compute this value of this y, right?
Yes, sir.
And f inverse has a property. What is that property? That
f of f inverse x equal to x.
x equal to
x.
right? So now f of f inverse this one. So
fy equal to x.
so f inverse x by definition it's y. So that means f of y
Equal to x.
equal to x. And what is f of y?
Y cube minus 5.
Correct. It's y cube minus 5, which is x. That means
y cube equal to x plus 5.
y cube, which is nothing but x plus 5.
Y equal to x plus 5 to the power 1 by 3.
Correct. Y equal to x plus 5
to the power 1 by 3.
1 by 3, right? So then my f inverse is nothing but x plus 5 power 1 by
3.
So to make sure that whatever I have computed is correct or not, what I need to do, I need to compose both the functions.
F of f inverse.
So f of f inverse of x
Equal to.
So this is nothing but f of x plus 5
to the power 1 by 3.
1 by 3. And by definition, f of x is nothing but x cube minus 5. So this is nothing
x
but
plus 5 to the power 1 by 3 ka whole cube.
Correct. This is whole cube minus 5, right?
5. Yes.
So this is nothing but
x
plus 5 minus 5
equal to x.
And the second condition is f of
inverse x. So
okay,
f inverse of fx.
Yes.
Equal to x.
So yeah. So what is f of x? F of x is x cube plus 5, right?
Yes, sir.
And what is f inverse?
X cube minus 5.
So minus 5.
Correct. Thank you. Yeah. So x cube minus 5. And what is f inverse of x cube minus 5?
So x cube minus 5 plus 5 to the power 1 by 3.
X cube. So in place of this x, I just need to write x cube minus
x cube minus 5.
5
yes.
plus 5
to the power 1 by 3.
1 by 3, which is nothing but x cube power 1 by 3.
1 by 3 equal to x.
So that basically means whatever we have computed, that is precisely the inverse of this function. So okay, so the thing is you have to apply this logic to find out the inverse of it. So the main idea is you have to write y in terms of x. Okay, once you are done with writing y in terms of x, then you have f inverse of x. Okay. Is it clear how actually we are computing the inverse of this function?
Yes, sir.
Okay.
A little bit down the page, please.
सर कल ग्रेडिंग पैटर्न में
Thank you,
चेंज
sir.
आया था सर, कंफ्यूजन उसके रिकॉर्डिंग.
Just a minute. Yeah. So this part is clear, right?
Yes,
Yes.
sir.
Okay. So what was your question? Some grading pattern?
Yes,
Sir,
sir. There is a mail regarding change in grading patterns.
Yes, sir. Quiz second and n terms related, sir. Some
Yes,
confusion.
they will not consider the quiz one score. This is right or wrong?
They will not consider.
Quiz one score. Only they will write quiz 2 and interim exam score to be calculated, or the total score.
No, I don't think so. Like I have to check. I am not sure. Like whether they have sent some. I guess something is not mandatory for writing end-sem exam. Some condition was there.
No,
but
sir.
Sir,
They will
sir, school
calculate
की recording.
actual score of quiz 2. And before that, they will consider the max of quiz 1 and quiz 2. And this time, they send mail about the quiz 2 actual score is they consider.
Okay, I guess so. Like I am not sure. Like I have to check with the course support team. Then only I can answer.
Okay, sir. But sir, this is how sir, in the ongoing term how the grading pattern is changed.
No, I guess not. The grading pattern is not changed. Like I am not sure. Like I have to ask. As far as I know, they have not some condition they have changed, not the grading pattern.
Sir, share the screen कर सकते हैं. Mail.
I'll ask the team and probably will respond in the next section. Next session. Okay, don't worry about it. Okay, you go please.
Okay, sir.
Prepare for quiz 2 exam. Okay, so I don't think there will be some huge changes. Okay, so some condition. As far as I know, some condition regarding this graded assignment is changed. Okay. So okay, and one more thing, don't worry about this pattern. Okay, so you better you go and write quiz 2 exam.
Okay,
sir.
Okay,
sir.
Sir,
I sent you the what mail we got. I did type on the chat box. Will you see?
Yeah, some calculation of this term quiz score is being modified.
No, sir. They will remove the concept of quiz one, I think, sir, because they are not mentioned the quiz one.
No. Actually, the only thing is they have probably some festival is there, right, on quiz 2 day. Okay.
Yes, sir.
Yeah, so because of that only, I guess they have modified the some like the calculation for quiz 2 course. They are doing it some differently. Okay, again I'll say don't worry about it. Okay, see you better go and write the quiz 2 exam. Okay.
Sir, can I interrupt?
Sorry?
Sir, can I interrupt?
Yes, please.
Sir, before, if we don't give quiz 2, 10% mark is get deducted, but this time they are not saying that this 10% will not deduct if someone is not give quiz 2.
Okay. Yeah, then that is the only difference. So yeah.
Okay.
Again, like yeah. So don't worry about all these things, and better you go and write the.
In quiz 2, something criteria like 40% or 45% of total score.
Yeah, something was there. I don't remember. Some rules are there. Like if you attend quiz 1 and quiz 2, and if you don't attend one of them, how your score will be computed, and if you attend, so there are different rules. Okay, so you can go and check that PDF. I don't really, I don't remember. I have seen all these things, but I don't remember.
Sir,
Hmm.
how much percentage of questions will come from 5 to 8 week and 1 to 4 week?
No, so the thing is, I guess we have said it multiple times. So we'll not ask any direct question from week 1 to 4. Okay. So the thing is, you may need some concept of week 1 to 4 to solve the questions of week 5 to 8. Okay. So you may need some concept, but we'll not ask any direct question from week 1 to 4. Okay. So, but it's better to revise the concept, because you may need some concept of week 1 to 4 to solve some question. For example, this 1 function, onto function, it's basically it is also in your week 1 syllabus, right? So it's better to quickly revise all these things. Okay, so that it will helpful for you to solve the questions of week 5 to 8. Okay. So the last question is clear, right?
Yes, sir.
Okay.
Yes, sir.
Okay, fine. Any other doubt?
No, sir.
Okay, fine.
Sir, kindly confirm the grading pattern change in the next.
Yeah, yes. That is not an issue. Again, I'm saying that is not an issue. You will get probably someone already said, right? Some 10% still.
Sir,
I will
please
ask.
confirm about the team.
Yes.
Okay.
I will ask and let you know. Okay.
Okay.
Sir, there will be one more lecture for the revision, right?
Yeah.
Yes,
Next
on Friday.
So yeah, so they in that session, like mostly will cover this calculus part. Okay, so week 7 and 8 will cover in that session. Okay.
So one more query.
Hmm.
Sir, will the grading pattern of all the weeks similar, or it will be like week 1 to 4 we have focused more on 1 and 4 week?
Hmm.
So with that thing in the mind, what will be the grading pattern of this quiz too?
No, grading pattern, certainly we are not going to disclose
No,
the
I
grading.
mean the focus on
Maximum focus on which week, like week in
week.
qualifier week 1 and 4.
No, it's so that certainly we are not going to disclose. The syllabus is week 5 to 8. That's all. And again, I'm saying like we'll not ask any direct question from week 1 to 4. But it's better to revise the concept, so then it will be useful for you to solve questions of week 5 to 8. And regarding the week wise weightage, we are not going to disclose.
Okay, sir.
Okay. Okay, then thank you. I'll stop the session.
Okay, sir. Thank you.
Okay.
Thank you, sir.
Thank you.